All right, welcome to video number 5. So it says Jasmine is helping at the marina prepare boats for the summer season. She needs to pull a heavy 50-kilogram aluminum canoe up a smooth concrete boat ramp out of the water. The ramp makes a 25-degree angle with the ground. As Jasmine and her coworkers pull with a combined applied force of 285 newtons parallel to the ramp, she notices that the canoe moves up at a steady pace. Her supervisor mentions that the aluminum canoe sliding on the concrete ramp creates friction that opposes the motion. Jasmine realizes they need to pull hard enough to overcome both friction and the component of the force's weight, pulling it back down. Understanding these forces helps Jasmine figure out the best strategy for moving boats safely with her team. Develop a mathematical model to determine the canoe's weight. So the mass is 50 kilograms. We're looking for FG. If you look at the equation on the reference table, page 2 under F net equals M times A, it says mg. We're on planet Earth. Again, we're only going to use the magnitude value, which means you're only going to write a positive number, because on the inclined plane, there's really not a very direct up and down, left and right. It's kind of like what's getting pulled into the surface, what's getting pulled down the slope of the inclined plane. So we're going to use positive 9.8 meters per second squared. So Fg is equal to 50 kilograms times 9.8 meters per second squared. So if you calculate that, you get 490 newtons. 21, construct a free body diagram that depicts the scenario given in the text. Be sure to draw all forces from the point E and label all forces. So we have pulling up the incline at a constant velocity, right? It says at a steady pace. So the force of gravity pulls downwards. Fn pushes up off the surface. It's perpendicular. We have an applied force going up the inclined plane, who's equal to opposite to Fn is Fg perpendicular. And then because you're moving up the inclined plane, you have the force of friction plus your weight parallel, right? Because that's the force that's always responsible for the sliding motion down the inclined plane. 22. If a canoe is moving up the ramp at a constant velocity, again, we know all forces to be balanced. Which of the following relationships must be true? So we know that the applied force has to equal the friction force plus the weight parallel, right? Because the weight parallel is the thing that's wanting it to cause it to slide down the ramp. And the friction force, because the object's moving upwards, friction opposes motion. Develop a mathematical model to determine the force of kinetic friction acting on the canoe as it is pulled up the incline at a constant speed. Okay. So we know, if we go back to our reading, the angle with the ramp is 25 degrees, the applied force is 285, and we just calculated a force of gravity of 490. So we have Fg equals 490. We have an applied force is 285 newtons. We have an angle of 25 degrees. Our unknown is the force of friction, or specifically kinetic friction. So again, you would actually kind of make this relationship. So Fn obviously always equals Fg perpendicular, and our applied force must be opposite to the friction force plus Fg parallel. So this is what your equation will be. Fa equals Ff plus Fg parallel. So you have 285 newtons equals Ff, the thing you don't know. But the problem is this guy right here, you don't know what it is. But you do know an equation to calculate it. So Fg parallel equal Fg sine theta. So Fg parallel is equal to 490 newtons times the sine of 25 degrees. Your Fg parallel will equal the following. 207.1 newtons. So you're going to take this number, you're going to plug it in right here. So plus 207.1. And then you're going to subtract it on both sides to get your force of friction. So the value of the force of friction would be 77.9 newtons. Okay, obviously it depends on where you round to, so your answer might differ from mine just a little bit. As Jasmine increases the angle of the ramp from 25 degrees to 35 degrees, explain what happens to the force she must apply to maintain a constant velocity. So as you recall, so as the angle increases, our weight parallel also is increasing, right? This object's natural desire to slide down increases, which means that if you want to keep it at constant velocity, your applied force must also increase because it needs to match whatever it is, the combination of friction and your force of gravity parallel. So, excuse me. So what you're going to say is as the angle increases, weight parallel increases. Oops, parallel. And in order for the object to continue moving at a constant velocity, the applied force must increase as well. Please understand when it's open-ended like this and I'm asking you to explain yourself, I'm obviously not looking for an identical statement that I have. I'm looking for something similar. So please keep that in mind. It's not like, oh, this is what's on the answer key. As on the Regents, it's kind of what we call norming, like what are other solutions that are acceptable. So please understand, it needs to be something along the lines of this. It doesn't verbatim have to be exactly word for word what I wrote. It just has to be something that falls under that category, okay? Number 25, the coefficient of kinetic friction between the aluminum canoe and the smooth concrete boat is 0.180. If plastic glide strips are added to the bottom of the aluminum canoe, the coefficient of kinetic friction between the plastic glide strips and the smooth concrete boat ramp becomes 0.035. Explain how using the plastic glide strips affects the amount of kinetic friction acting on the canoe. So what they're giving you is this coefficient of friction, right? This mu value. And this is a ratio of the smoothness between the surfaces, right? So this is a value that's either between 0 or 1, right? That's the range. 0 means it's smoother, so you have less friction. And if it's a number that's closer to 1, that means it's very rough and you have max friction. So again, if you're a number that's closer to 1, you are very rough. When you're closer to 0, that means you're very smooth. So if we take a look at these numbers, we see that 0.035 is much smaller than 0.180, right? So this number is obviously closer to 0, meaning that the amount of friction is reduced compared to what it once was. Okay, so using the plastic, glide strips reduces, if I could write, the kinetic friction as the coefficient of friction is significantly reduced, meaning there is little friction. Between the plastic and concrete. Okay, let me read that over. Using the plastic glide strips reduces the kinetic friction as the coefficient of friction is significantly reduced, meaning there's little friction between them. Yep, perfect. Okay, nice. All right, so this is the conclusion of the 5th video. I'll see you in the 6th one.